Now we will talk about the neutrophils in detail, right? Few important points about the neutrophil. The first most important point is the neutrophils are the most abundant white blood cells, right? They're the most abundant white blood cells. Secondly, not only they are most numerous, they are most motile. They are first to reach. They are first to reach at the site of inflammation in big numbers. That is why, because they first of all reach at the site of inflammation in big numbers and infiltrate the injured tissue, they are said to be cells of acute inflammation, right? Again, number one, neutrophil the most, yes please, abundant cells, abundant white cells. Number two, that they are most motile. So they are the first to reach at the site of inflammation. So they are called cells of, yes, cells of acute inflammation, right? Number four, of course, you know that their size is about 12 microns and they are having multilobed nucleus, right? And they have primary granules, and important thing about the primary granules is that primary granules, okay, I make it like that, primary granules are full of acid hydrolases. Primary granules are full of acid hydrolases. With that, primary granules also have myeloperoxidases. Primary granules, they have acid hydrolases, plus they are having myeloperoxidase enzyme, which help in the production of hypochlorous acid. Neutrophils, when they're fighting with the microbe, they use myeloperoxidase enzymes and produce this product, right? This product is highly toxic for bacteria and other microbes. This is one of the killer products by the neutrophils during their fight with the microbes, right? Plus, primary granules also have something called defensins. These are special protein molecules which are concentrated in primary granules, defensins, and they work functionally like immunoglobulins. These are not immunoglobulin molecules, but they work like immunoglobulins. These are primary granules, right? Moreover, they are having specific granules which are also called secondary granules. Already you know what were the different names of primary granules? The four names of them. They are called primary granules. They are also called non-specific granules. They are also called, yes, xerophilic granules, and they are also called lysosomes, right? So these are the primary granules, and they do have secondary granules as well, right? And primary granules, they appear at which stage of development? Remember promyelocyte. This is P, so it should appear at promyelocyte. Is that clear? And secondary granules appear at which stage? Imad, you will remember that because it is primary granule for P, it appears with the which cells? Promyelocyte. Is that right? So these are secondary granules, right? And they appear after that stage, after the promyelocyte stage. Which was the stage? Myelocyte, right? And myelocyte has secondary granules or specific granules, right? Now, secondary granules, or you can say specific granules, right? Okay, let me make it like this. They are having which product? Anyone who knows that what are the special substances which are concentrated in secondary granules? Yes, tell me. Lysozymes. Lysozymes. Please don't confuse it. These are not lysosomes. Lysosomes are the primary granules. These are protein molecules which are called lysozymes. These are special enzymes which specifically break down the bacterial cell wall. Lysozymes are a special product, right, which are bacterial cell wall cutters, right? So the lysozymes, and there are lactoferrins. Ferrin from ferrous. Ferrous means iron. Lactoferrins are the molecules which are present in secondary granules, the specific granules of neutrophils, which extract from microbe iron. Is it right? And that then when iron is pulled out of the microbial structure, then microbe enzymes don't work. Iron-dependent enzymes don't work, and microbial metabolism fails. Then there is alkaline phosphatase there. Alkaline phosphatase. This is an enzyme, right? And there are many additional bactericidal, bacteriostatic, and bactericidal products. Bacteriostatic mean that these products don't allow the bacteria to grow, so bacterial growth becomes static. And bactericidal mean the bacteria are really killed. So which are more dangerous, bacteriostatic product or bactericidal? Yes, bactericidal, right? So you can say that there are primary granules as well as there are secondary granules. Primary granules have acid hydrolases and they are having myeloperoxidases and defensins. These are three important components, right? And then secondary granules or specific granules, they are having lysozymes, not zomes. Lysozyme are enzyme, lactoferrins, alkaline phosphatase, and many other bacteriostatic and bactericidal products. And neutrophil has specifically tertiary granules also, right? Tertiary granules. And tertiary granules have which product? Yes, who will tell me? Tertiary granules have special cutters, enzymes. You know, when neutrophils come out of the blood, they have move through the connective tissue. When neutrophils come out of the circulation, they have to burrow their way or make their way through the connective tissue to accumulate at the focus of injury. So these are the tertiary granules, which are certain enzymes which can help the neutrophil to digest our connective tissue, so that through the connective tissue, like rabbits, they can make their way, right? Yes, these enzymes are like collagenases, or there are hyaluronidases, right? These are the enzymes which can break down our connective tissue, or gelatinases, right? Any question up to this? So these are the granules which are present in neutrophils, right? And then we come to another important killer feature of the neutrophils, that when neutrophils are fighting against microbes, they produce highly reactive oxygen-derived radicals. You know, neutrophil, when they are very active, this is a very active neutrophil, right? Going to eat up this bacteria, which is not knowing what is going to happen. This happy bacteria dancing around doesn't know that neutrophil is coming to eat it, right? Of course, you must be knowing that neutrophil has primary granules, right? Moreover, it has secondary granules, and it does have also tertiary granules, and it has a very special quality that it will take from the environment simple oxygen, molecular oxygen. Molecular oxygen is not reactive oxygen. And by action of certain enzymes, right, there are some enzymes, I told you previously, myeloperoxidases, and there are some other enzymes which are present in the membrane, and these are called membrane oxidases, right? These can work on what? On simple molecular oxygen. These enzymes can work on simple molecular oxygen, right? And then they can convert molecular oxygen into superoxide radicals, hydrogen peroxide radical, hydroxyl radicals, and especially myeloperoxidases produce HOCl, hypochlorous acid. All these products are very, very dangerous, and these are as a group called oxygen-derived free radicals or oxygen metabolites, which are produced by neutrophils, as well as macrophages also produce these products, because oxygen is present in all the tissues, and they simply convert non-reactive molecular oxygen into dangerous derivatives, and these derivatives react with the component of microbe, and then you can imagine what will happen to microbe. It will forget its dance, it will be lying over there with the legs in an odd position and eyes having what? Tears. Is that right? So this is what you have to remember, the neutrophil and macrophage. Not only they release their product from lysosomes, which are primary granules, or from the secondary granules, they release bacteriostatic and bactericidal products, but they also have a capacity to convert molecular non-reactive oxygen into highly reactive and destructive oxygen-derived metabolites or radicals. Is that right? Which may be superoxide or hydrogen peroxide, or they may be hydroxyl or hypochlorous acid. This is very, very toxic, and it is produced with the help of myeloperoxidases, which are concentrated in which granules? Primary granules. Myeloperoxidases. Right? This is also called respiratory burst reaction. Another thing which is important is that neutrophils. Yes. Do you want to really know how neutrophils during acute inflammation come out of blood vessels and how they move to the focus of infection and how they kill the microbe? Are you interested in knowing that, or we omit it? We'll study it in patho. Hurry up.
Yes.
You want to know it? Okay. Let's see how the neutrophils really come into action. I'll talk very briefly. Let's suppose here is your circulation. There is some capillary here, or there is another capillary here, and there is another capillary here. And let's suppose here are your cells, right? And a dangerous bacteria come here. These bacteria are supposed pyogenic bacteria, very, very toxic. These bacteria start damaging your cells, right? Of course, when tissue is damaged, we say tissue gets inflamed, and during acute inflammation, neutrophils from the circulation should rush towards the site of injury to eat up the bacteria, as well as destroy and eat up the bacteria, and also to remove the injured cells. Is that right? What really happens when, suppose we are taking an example of staphylococcal bacteria, which is coming here, or any pus producing bacteria, right? And those bacteria are damaging your cells, right? When cells are injured, they produce the products which are called chemical mediators of inflammation. What are they called? Chemical mediators of inflammation. So injured cell produce a lot of products, especially mast cells. The mast cells which are present around the blood vessels, and when mast cells are injured, right, they release prostaglandins, leukotrienes, histamines, interleukins, and many other products, right? And those products will control the different steps of inflammation. During inflammatory process, number one, arterioles dilate. So in injured area, when arterioles will dilate, blood flow will be increased. So there is increased blood flow. That is why injured area become red and hot, right? Because at the site of injury, a lot of chemical mediators of inflammation are produced. Many of these are arteriolodilators. So blood flow in injured area increases. Secondly, a very important change occurs in endothelial cells. These are the healthy endothelial cells, right? As soon as chemical mediators come and work on the endothelial cells, normal endothelial cells have receptors for many chemical products of inflammation, many chemical mediators. Now what really happens, let's suppose histamine come. Histamine will work on in its receptors. Prostaglandins will work over here. Tumor necrotic factor will work over here. So many chemical products which are produced by in the zone of inflammation, they work on the nearby endothelial cells, and endothelial cells undergo changes. Number one, they shrink. When they shrink, right, every endothelial cell, when multiple endothelial cells shrink, they produce interendothelial gaps. Endothelial cell produce interendothelial gaps, and through this gap, lot of protein-rich fluid will come over here. Right? When lot of protein-rich fluid will come over here, this area will develop swelling. Already it was red and hot, and now it will become swollen because its microcirculation around this injured area has become more permeable. I'm not teaching you inflammation, just a little bit talk about how the neutrophils come there. So again, whatever the cause of injury, this tissue is acutely inflamed. In this tissue, injured cell and injured mast cells, and maybe even white cells will also come. All of them produce chemical mediators of inflammation, chemical substances which mediate the different steps of inflammation. First step is there are vascular changes, and then white blood changes. In vascular changes, there is arteriolodilation, and blood flow increase in this area become red and hot. Then what really happens, that chemical mediators of inflammation, many of them work on the endothelial cells. Endothelial cell shrink and they undergo morphological changes, and there is appearance of interendothelial gaps. Through that, because blood flow is more, so pressure in this area is more, at the top gaps are more, so protein rich fluid comes out. And this protein rich fluid which is coming out, this is also called exudate, and this produces swelling. Moreover, there is another change. These injured endothelial cells these endothelial cells which are activated by the chemical mediators of inflammation, they start expressing certain molecules, and these molecules are going to hook the white blood cells. These molecules are like hookers. They will hook the white blood cells, because white blood cells were just, when this endothelium is healthy, they were just coming from here and they are going from here. But once this endothelium has been treated by the chemical mediators of inflammation, right, they develop hookers, so that white blood cells, rather than just passing by, they should get hooked over here. Is that right? Am I clear? They are not called hooker molecules, they are called adhesion molecules. Is that right? I don't want that you come up with special terminology, right? These molecules are called adhesion molecules. And look at it, these affairs are always bilateral, right? So meanwhile, when neutrophils are passing by this area, they are also under the influence of chemical mediators. They also develop corresponding adhesion molecules. This is what happens at the site of injury, right? The blood vessels dilate, blood flow increases, interendothelial gaps appear, especially histamine help the endothelial cell to shrink, and histamine act on these cells so that they develop adhesion molecules, and some of chemical mediators act on the passing neutrophils, and neutrophils also develop adhesion molecules. Is that right? Now, these adhesion molecules, there are two sets of adhesion molecules. So initially, the group of adhesion molecules which appear on both sides, they help these cells to loosely attach here. Is that right? And then second phase of adhesion develop when these cells tightly become adherent. Initially, the molecules which appear here, these are called selectins. What are these called? Selectins. They are going to select the white blood cells, especially neutrophils. And neutrophils have receptors, and these are called, yes, sialylated sugars. Of course, you are selected by the sugary things, isn't it? When you meet first time, you want to be in good relation, you try to be very sweet. Is that right? Same happens here, that endothelial cell express the selectin molecules, and neutrophil are going to respond by sialylated sugar molecules, right? So these are the, you can say, sialylated sugar molecules. So what really happens, that this neutrophil has all over sialylated sugar molecules, and it is expressing different type of selectins. So in a way, in this zone of inflammation, endothelial cells are altered as well as neutrophils are altered. It's a different business going on in the street. So what will happen, that these cells which are normally moving in the central flow, in healthy blood flow, white blood cells are in the center, right, and red blood cells are on the sides, because white blood cells are larger, red blood cells are smaller. The rule of life is that bigger things take the central role and smaller things are marginated. So in the healthy blood flow, bigger cells are white blood cells. So usually in a healthy blood flow, white blood cells are in the center of the flow. On the side, there are red blood cells. On more periphery, there are platelets. They are smaller, 1 to 2 micron. And extreme periphery with the endothelial cell, there is plasmatic zone, cell-free zone. This is how the normal blood flow is going on. But in site of inflammation, blood flow becomes more due to arteriolodilation, and a lot of fluid is exudating out. Do you think under these circumstances normal blood flow can be maintained, or blood flow will become really slow in this area? More blood coming to this area and less blood leaving. You know why? Because when blood is coming here due to arteriolodilation in bigger amount, but the fluid leaks out, so cells become concentrated, blood becomes viscous, So it will move out fastly or slowly? You know, these areas traffic will become, as you must be knowing, traffic becomes slow. Is that right? Now, when traffic becomes slow in these areas, then what happens? RBCs come together. They're smaller, they cling together. And groups of RBCs become larger than individual WBCs. In an inflamed area, when groups of RBCs come together due to slow blood flow, you are understanding why? Right? Because even though more blood is coming, due to fluid oozing out, cells become more concentrated, and blood becomes thickened or hemoconcentration is there, it becomes more viscous, so slow to move out. So pressure in this area increases, so more fluid comes out, plus because flow is not well maintained, things are no more in laminar fashion. And RBCs are making somewhat small aggregates, and groups of RBCs become larger than what? White blood cells. So groups of RBCs will kick the white blood cells, and white blood cells from the central zone will be pushed out to the periphery. This step is called that white blood cells are, or neutrophils are marginated. So what really happens, the initial cellular events are during injury that in the microcirculation of inflammation zone, white blood cells are marginated. When they come on margination, of course, they are near to now what? Very, very receptive? Endothelial cells. Endothelial cells have developed what are these molecules? Selectins. And they are having sugars. They are also trying to be sweet, isn't it? Now they are trying to be sweet and they are trying to select whatever they want to select. Now what happens? Neutrophils are pushed from the axial area and they are marginated. They come near to these very sticky endothelial cells. Right? So when neutrophil come here, suppose this is an endothelial cell, there is this wall is like endothelial cells wall, and I'm the neutrophil, right? They are having a lot of selectin molecules, and I have developed sialylated sugars, right? But they interact loosely with each other. So what will happen? As soon as from central zone, I was moving in the center, then I'm marginated, I come on the margin, few molecules interact, but because blood is pushing me, so I start rolling like this. Right? You know, happy neutrophil. But meanwhile, more inflammatory zone come, inflammatory chemical mediators come, and they convert another group of surface molecules. These surface molecules are normally, these are two molecules, they are normally in inactive phase. These are called integrins. When more chemical mediators come, they shift into active state. And meanwhile, they develop also more second phase of adhesion molecule. First phase was selectins and sugars, sialylated sugars. Is that right? Second phase is integrins on neutrophil surface become more active state. And here there are some molecules which say ICAM, VCAM. ICAM, VCAM. I don't want to say anything. So these molecules are called ICAM and VCAM. It doesn't mean I mean I came and we mean we came. VCAM is vascular connective tissue adhesion molecules. ICAM is intercellular adhesion molecule. Anyway, you simply remember first group is selectins with sugars, which lead to loose attachment, and there second is ICAM, VCAM with the activated integrins. Right? It is just like this, that these are my inactive integrins. Right? And when you start rolling and more chemical mediator work, it's open up to start action. So what is it now? Active integrins. And what is on the other side? VCAM and ICAM, receptive phase. So what really happens? Again, leukocyte was coming in the center, isn't it? When my circulatory pattern change, leukocytes get marginated. There are endothelial areas. So endothelial cells are expressing selectins and I'm expressing sugars, trying to be sweet. And then they are loose attachment system. So white blood cell and neutrophil hit here and then it start rolling. But then what happens? A very active integrins come. And when integrins come, they catch it by ICAM, VCAM, and now it stop rolling. It tightly stick with the endothelial cells. Is that right? you will find soon that all the endothelial cells are lined by white blood cells, neutrophils. This process is called pavementation. Is that right? So initially there is rolling, which is mediated by selectins. Then there is tight adhesion, which is mediated by integrins. Is that right? After that, another group of molecules appear. Now this is a white cell which is sticking here. Is that right? Very tightly, integrin and ICAM-VCAM interaction. Then what happened? Histamine-mediated intraendothelial gaps appear, and in this gap, especially this area, very special type of molecules appear, right? And corresponding molecules appear. There's P appearing here, and there is P appearing here. This P stands for PCAM. Is that right? So PCAM appear here and here, and this PCAM of they are homologous molecules, similar on both cells. They interact with each other, and when they're interacting, this cell starts slipping through this. There's a PCAM interaction which helps this cell to slip in between the intraendothelial gap, and then this cell will come out of endothelial lining, here basement membrane. It will rest a little bit and then produce collagenesis, break down the basement membrane, and come into where it is present now. Extravascular space. This cell has extravasated. It was going home, now what happened here? This was a special area, and in the red hot area due to inflammation, of course, right? This cell, which initially started rolling, then adhesion, and then extravasation, or we can say transmigration from vascular area to connective tissue. And this type of problem will occur. Not only white blood cells and neutrophils will come from this microcirculation, but from here also, and from here also. So what really happens at the site of injury, we find a lot of neutrophils, which are most abundant cells, and they're most motile cells. They're coming out of blood vessels, and they're ready to accumulate towards the site of, yes, injury, at the focus of injury. I hope it's clear to you what happened up to now. First step was margination, then there was rolling, then there was adhesion, then there was transmigration, and then they will move towards the focus of injury, and this is called chemotaxis, and eventually they will eat up this bacteria by phagocytosis. Up to now what we have discussed, margination is a hemodynamic event, then rolling is mediated by selectins and sugars, then adhesion, tight adhesion and pavementation is mediated by integrins and ICAM-VCAM, and then transmigration is by corresponding PCAMs. And when it comes out, now they have to move towards the focus of injury. It means from here like this, and from here like that, from here. Now the question is that how the neutrophils know where to move, in which direction once they're out of circulatory system. How they know? They don't have eyes to see where the bacteria, and they don't have nose to smell, but they have chemical sensors. Because chemical substances, look, are being released by this zone of injury. These are chemical chemoattractants, like a good smell. Chemoattractant. There are many chemoattractants which help these cells to undergo chemotaxis. These classically, the chemoattractants you are supposed to know is C5A. It's a breakdown product of complement protein, and leukotriene B4. These two molecules are present abundantly at the site of inflammation. So what really happens, that these products concentration is increasing progressively towards the focus of injury, and these cells have receptors for these chemoattractants, which are also called chemotactic agents, or some bacterial products are also chemotactic agents. So neutrophils have receptors for chemotactic agents all over its surface. Right? If chemotactic agent bind here, it start moving in that direction. If it bind here, it start moving in that direction. It's just like I'm the neutrophil. I've just come out standing here. Now on my surface, I have multiple receptors for chemotactic agent. Now, if bacterial infection is maximum at that area, then chemotactic agent will more bind here and less on other side. So wherever chemotactic agent bind with the receptors give signal to the neutrophil, and neutrophil develops microfilaments and microtubules towards that area which is stimulated by chemotactic agent, and it start drifting to that side. Is that right? So what really happens, that first it will marginate, then it will roll with selectins and sugars, then it will integrate with integrins and PCAMs, ICAMs, and then it will move out through PCAM, right? And then wherever it is touched by the chemotactic agent, it start drifting to that side. This is called chemotaxis. What is chemotaxis? Directional movement of white blood cells determined by the concentration of chemotactic agents or chemical substances, right? Chemotactic agents. So by these things, it will eventually reach at the focus of injury. Once they have reached to the focus of injury, then they have to attach with the bacteria. For example, if this bacteria is producing injury, and then engulf it and destroy it. That whole process is called phagocytosis. Phagocytosis process has 3 steps. Let's suppose there is a neutrophil which is coming here. This has come here. I think he needs some dentist help. Now, this neutrophil is over here. Now what it will do? First, it should attach with the bacteria. Especially, okay, if you are, if I give you the bread to eat, if it is having jam on it, you will like a bread with jam or without jam? With jam. You eat it more enthusiastically. Same is true about neutrophil. They like the bacteria with jam. What are the jam for bacteria? There are some special molecules. If those molecules are sticking to the surface of bacteria, their corresponding receptors are present on the neutrophil. And such bacteria which are, you can say, coated with certain molecules, these molecules are C3b or antibody IgG. If bacteria are coated by these molecules, such bacteria or such particulate matter is very eagerly, you can say, phagocytosed by or engulfed by the neutrophils and macrophages. Such molecules are called opsonins. What are these? Opsonins. Opsonins are the molecule which facilitate the phagocytosis. Is that right? Because on one side they can bind with the microbe, on the other side they can stick, they have receptors on the neutrophil or macrophage. So you can say, now it opens its mouth, right? And this bacteria is very, very sad. Why it is so sad? Because it is already having the opson in it, and here's the opsonin receptors. So as soon as these two interact, this membrane becomes very active and put pseudopores around it and engulf it. During this process, as you know, there are myeloperoxidases and membrane-bound oxidases. So there are so many ways to kill it, right? One way is that it converts the molecular oxygen into superoxides or hydrogen peroxide or, yes please, hydroxyls or HOCl. So all these products are very bad for bacteria. Or it simply engulf it into phagosome, and once bacteria is inside in the phagosome, right, here is the bacteria, it will fuse with that primary or secondary granules. You remember? Primary granules are also called xerophilic granules, non-specific granules, or simply lysosomes full of acid hydrolases, defensins, and defensins and myeloperoxidases. They will release their content into this phagosome. Lysosome will fuse. When they fuse together, we call it phagolysosome. Plus secondary granules may also fuse, and they have bacteriostatic and bactericidal products. You remember secondary granules which were having what? Secondary granules. Lysozyme. Yes, very good. And they were having lactoferrins. So anyway, this bacteria will be killed. But you know, do good, have good. Oh, do bad, have bad. During this process, many neutrophils also die. In this battlefield, eventually what you find, lot of protein-rich fluid accumulated here. It's like a battlefield. Lot of alive, dead, and dying local cells. Lot of alive, dead, and dying neutrophils. Lot of alive, dead, and dying microbes. And all this collection here, local cells which are necrotic, bacteria dead and dying, crying, and what is that? your neutrophils also injured, like a battlefield, really nasty war. In the end, what is there? Protein-rich fluid with a lot of neutrophils, lot of bacteria, lot of local cells, all of them, some of them alive, some of them dead, some of them dying. All this collection is called pus. Have you heard of pus? All this collection is called pus. Is that right? But the process is that anyway many bacteria will be killed. Eventually pus will be draining and or macro. Another important thing which I would mention, a neutrophil reach there within few hours, but they don't last more than 12 to hours or 16 hours. So neutrophil keep on coming wave after waves, they keep on fighting and dying. But before the death, they release chemical mediators and call their stronger friends. Who are those? Macrophages. So as the second wave, endothelium undergoes changes and develops sticky molecules for macrophages, and macrophages start coming here and they fight well there. So actually, within few hours of inflammation, there are a lot of neutrophils. Then monocytes and macrophages come there. So there are two types of acute inflammatory cells, neutrophils and macrophages. And if fight really become very long, then macrophages call the lymphocytes over weeks and months. That is why in chronic inflammation, the cells are macrophages and lymphocytes. So this is very important, that acute inflammation and chronic inflammation. Cells of acute inflammation are neutros and macros. Monocytes convert into macrophages, they come into when they come into tissue. And cells of chronic inflammation are macro and lymphos, right? So when we talk about acute inflammation, you will talk about these two cells. And when you talk about chronic inflammation, we talk about these two cells. Because in acute inflammation, a lot of neutrophils are there. Neutrophils have a nucleus with multiple morphology, so we call it polymorphs are there in acute inflammation. In chronic inflammation, cells are present with single nuclei, so these are called mononuclear cells. So usually we say in acutely inflamed tissue, polymorphic cells are there. White blood cells are polymorphic, and in chronic inflammation, there are mononuclear cells over there. Am I clear? No problem up to this? So we were talking about your funny friends, neutrophils. Another very important thing, neutrophils have a lot of glycogen granules, so that in the time of need, they can break down glycogen to glucose, and they keep on supply of the glucose even when there's no oxygen, so that anaerobic glycolysis can occur. Normally glucose can be broken down into pyruvic acid, and after that into Krebs cycle, you use a lot of oxygen to produce ATP. But at the site of inflammation, there may not be much oxygen. Right? Under those adverse circumstances, neutrophils can still work by breaking down a lot of glycogen granules and still producing some energy for themselves. Is that right? So they have arrangement for the anaerobic glycolysis. And in the end, before I really close the neutrophils are the cells related with innate immunity. You know what is innate immunity? Innate immunity is non-specific immunity. There's two types of immunity. There's innate immunity and there's specific immunity. Innate immunity is non-specific immunity. For example, neutrophil may attack any type of bacteria. So they are non-specific in their defense mechanism. But if you talk about T cells and B cells, they are pre-programmed against a particular type of microbe. So they are specific for their action. So innate immunity is like natural immunity, or like what? Yes? Non-specific immunity, and usually with repeated attack of microbe, innate immunity does not go up. Right? Classical cells in innate immunity are your neutrophils, monocytes, and macrophages, and of course natural killer cells. These are the cells of innate immunity. But the cells of specific immunity, which is also called adaptive immunity, the cells are T cells and B cells and plasma cells, which are active B cells and producing antibodies. Is that right? After repeated attacks, specific immunity gets a boost. It becomes progressively more stronger. But innate immunity remains at the same level. So again, innate immunity is the first line of defense against microbes. Specific immunity is activated after the little time. Secondly, innate immunity is naturally present and it non-specifically protects the body against multiple microbes. Specific immunity so the certain components like certain T cells and B cells only work against a specific organism or antigen. Innate immunity with repeated attack does not augment or amplify, but specific immunity or adaptive immunity with repeated attack of a single antigen coming in the body, they get amplified in their response. Innate immunity does not have any memory. Specific immunity does have memory. Innate immunity is phylogenetically old type of defense. Specific immunity is a modern type of defense mechanism in our body. The cells of innate immunity are, yes, neutrophils, macrophages, and natural killer cells. You remember, natural killer lymphocytes may attack any cell, many different type of cells. And cells of the specific immunity are especially T cells and B cells and activated B cells producing antibodies, which are called plasma cells. Let's have a break.